Welcome back, guys. So far we've learned about closures, what they are, and how we can implement them in JavaScript. So now we are looking at the advantages of closure. First one is memoization. Memoization is storing. It's defined as storing the result of previous parameters in a cache. So if the same parameters occur again, we can simply find the result in the cache and return it. We do not have to compute the function. All right. So we have, for example, let's say we want to calculate a plus b, and a is, like, let's say it's 5, and b is, let's suppose, is 6. A 5, b is 6. So we can calculate the result and it will return the result, right? So we're going to compute the function. So next time, let's say if we come across these two values again, 5 and 6, then they will be fetched from cache. The same parameters are passed again. The result will be fetched from cache. So that's the whole gist of memoization. Let me write a function to elaborate on it. So let's say function is calculator, and this is forming a closure. We can create another function calling it add num, and we can return this function over here. And now here we can simply call the function calc equals to calculator, and call the inner function in console log res. Let's say you want to add plus 10 to the number, right? So how we can do? We can simply do return num plus 10, right? But we have to store the result in cache. So what we can do? We can simply do is return. First we can store the result. Let's say result is num plus 10, and we can put it inside cache. So let's declare a cache over here. It's nothing but a simple JavaScript object. Let cache and cache num is res. So what's happening over here is that we have this object of cache object. It will have num, which will work as key 10, and the result, which will be 20. So it will store results like this. For example, next time we get 15, then result will be 25. So we will be creating an object like this and be storing the result inside cache. So let's say next time we come across the same parameter 10, which appeared earlier, this one, we don't have to calculate the result and store it over here. We can simply search for this key, scan the parameter, and we can say, oh yeah, we got the result. We can return the result 20. So that's the whole approach of memoization, right? So we can return the cache num. What we did over here, we simply calculated the result, store the result in the cache with the key as the parameter, the same thing as parameter, alright? And then we can return this part, which is the value part of this cache key, right? Now let's consider a scenario if this number exists already. Then we don't want to do this calculation, right? We don't want to waste our time and memory. So we will simply check here if num in cache. This is the operator to check for keys present in an object. If it present, you can simply do return cache of num. Return cache of num. Alright. And if that's not the case, then we'll come to this part, do the calculation, put the result in cache, and return the result to us. Alright. It's as simple as that. Now we can put a console log over here to check if the value is being fetched from cache or is being calculated. Fetching from cache. Alright, and if we come to this part, we can put a console log saying computing. Alright, we have the number, let's say 10. Okay, let's check. For the first time around, it's computing. Alright, let's pass 12. Now it's computing because we do not have 12 in the cache memory. Or let's pass 10 this time again. Now it's calculating, computing again. So what really happened is that num in cache is coming here. Add num, we are passing calc is add num. So it's checking if num in cache, returning num. What is the value of this part? Let me check from using debugger. Oh, it's not working, so I think we can debug it ourselves. Num in cache. What is num? Num is 10. 10 already present in cache or not? Cache num equal to res and cache num. I guess there's some issue with it. The issue is we have cache over here. It's empty first time around. We get num, which is 10 first time, and then we get 20, and then let's run it again. It's computing again. Let's print the cache. What cache we are getting over here? As soon as we call it. It's empty. Alright, makes sense. Let me get rid of this again, and we can do it again, computing. Now we can do cache. Let's do cache, return cache num equal to num plus 10. It's again empty. Done add num. How come we have this object? We come here, console log cache. It's empty first time. Alright. We try to find num in cache. I can't find it. Alright, we do console log computing. We compute the result, put it here, and return it. Then the next time we call it, let me call it over here again. Calc res2 equal to calc 23 const res3 equals to calc 10. Alright, first let's check for res. Okay, now we got it. Okay, because we didn't even call the function, we're only calling it first time around. Right, so if we call it first, we get 10. We have this cache 10, 20, and it's computing, and second time it's also computing because we haven't come across this parameter before. Okay, so third time is fetching from cache because 10 is already present in cache. It's simply returning the key, which is the result of this parameter, right? That's what happening. If we do it again, const res4 calc 10, then we can simply we can do 4. Yeah, so fetching from cache twice, because in these times we are only calling with parameter 10, which is present in cache, right? So this is how we can memorize a function using closure. We can create a inner function which forms a closure around it, and this is the lexical environment. So this value the cache will be returned even after this function finishes execution, right? That's what we studied in the previous lectures. So the value will be returned in memory, and we can store the result in the cache, so we do not have to go through computation again and again. So it saves us time and space in memory. Right, guys, so I hope you understood the topics. If you have any doubts, please let me know in the comment section.